Hey innovators, it's Rick Blau. It's Wednesday the 19th and the Dow just hit 8,000. So it sounds like the entire world needs a little bit more innovation. So join me for TRIZ video blog number 3, The Pillars.
In TRIZ, we describe innovation of engineering systems and processes. Engineering systems are things, or an assemblage of things, that were designed to perform a certain task, or in TRIZ terms, its main useful function. Engineering processes are simply a series of manufacturing steps used to create something. Processes can be as simple as making tea, or as complex as manufacturing computer chips.
These systems have advantages and, more importantly, disadvantages. And humans strive to improve these systems. Why? Because every system consumes space, time, money, resources.
TRIZ provides 4 main pillars to help us innovate.
1.
Pillar number 1 is ideality. Lots of systematic innovation methods refer to ideal states, but few actually go so far as to quantify it. Lawrence Miles started value engineering theory in the mid-1950s, and he showed that the value of any system could be shown thusly. Basically, the value of any system can be described as the sum of its functions over the sum of its costs. Systems tend to evolve over time towards ideality, i.e. providing more and more functionality for less and less costs, until, by the way, a perfectly ideal system is where we get all the functionality with zero cost, i.e.
2.
As I mentioned before, every system was designed to perform a function. Now it turns out that people don't buy systems themselves, they actually purchase functions. For example, I don't go out and buy a watch because I want a watch. I buy a watch because it allows me to tell time.
Altshuler defined functionality by the following format: subject, action, object. At the highest level, this forces one to describe the system in regards to its main useful function, what job we expect it to perform. For example, a screwdriver transmits torque. A car transports driver. A pen informs a person. Although seemingly simple, this can get a bit tricky. We'll devote at least one full vlog to functional descriptors alone. But for homework, see if you can define the main useful function of the engineering systems that I showed at the beginning. Remember, solutions change, but functions stay the same.
Tong hong, wrong ee.
From his patent research, Altshuler recognized that engineering systems evolved by resolving what he called contradictions. Simply explained, a contradiction is a struggle of the functionality of parameters inside the system. Usually when faced with these conflicts, our first response is to simply compromise or trade off, to optimize the system. But Altshuler recognized and categorized a list of 40 inventive principles that people use to solve these contradictions, and we'll devote lots more time to these in future vlogs.
4.
Pillar number 4 is space-time interface. Certainly our problem exists now in the present, but looking at the entire space-time interface can yield some very interesting solutions. More about that later.
5.
Pillar 5 is analysis of resources. TRIZ defines resources as some material or energy that is not used to its fullest potential. TRIZ has a number of tools to help us locate and use those untapped resources, and we'll tackle those in upcoming sessions too.
Perform functions. And it turns out that people don't buy functions. People don't buy systems, they actually buy functions.
This could be the outtake.
Hey guys, I ran over this week, but to make it up for you, I left a small mistake in the video. If you find it, and you're the first one, send me an email and I'll send you something special.